What's going on, everybody? Johnny Bannon here at Trepa Technologies. Today, we're going over Domain 4.1 of our Network Plus full free course. Like, subscribe if you enjoyed the content, tell your friends, hit that bell, and let's go ahead and jump right into it. So I'm gonna zoom my face out of here. So we're going over Domain 4.1, which is explain the importance of basic network security concepts, and we're gonna go over logical security. Now here's the full objectives. We're going to make another video going over the right side of the screen here. Today we're just going over logical security. We're just going to go over encryption, certificates, IAM, and all the different AAA protocols, which we're going to get into, but authentication, authorization, that we have to know about. Really authentication protocols, you can see it there on the screen. And then lastly, we'll talk about geofencing. In our next video, we'll go over the objectives on the right and this objective as well. Okay, so we're going to start off with encryption for our logical security. So encryption is the key part of protecting data and ensuring its security. So if we go back, well, if we think about our CIA triad, which I don't know if we've gone over yet in the Network Plus course, so I got so many courses going on in my head, and Security Plus like the first thing you learn. But confidentiality. How do we make sure that our data that may sit in plain text in our trusted environment, when it leaves our untrusted environment, how do we know that it's protected? How do we change that to ciphertext or make sure that anybody looking at our sensitive data can't actually read it? That's with encryption, right? So encryption, long story short, changes plain text into ciphertext. It protects our data. There's going to be a couple different states that our data is going to live in, and it's going to affect how we apply encryption. Some key characteristics of encryption. Data protection, obviously. So prevent unauthorized access and ensure confidentiality. And then we have the different algorithm types, the different types of encryption. We have two major categories called symmetric encryption, which has a single private or shared key that's used, and you get a lot of different scaling issues with that, but the compute resource isn't as intensive for symmetric encryption. It has its place in our internet architecture, especially when it comes to TLS and PKI, the public key infrastructure. We have asymmetric encryption. That's going to be things like RSA, which has a public and private key, but more accurately just a key pair, where we create two mathematically related key pairs in asymmetric encryption, and one key encrypts, the other key has to decrypt, and vice versa. And then we call those public-private key pairs. Asymmetric encryption is going to enable us to share symmetric keys securely. Not going to dive too deep into that, but essentially that's with algorithms like Diffie-Hellman, elliptic curve cryptography. Both are used in our architecture when dealing with encryption, and both have their own use cases, okay? Authentication. So encryption can also be used to ensure the integrity and authenticity of data, verifying that it has not been altered during transmission. That's kind of getting more into hashing and digital signatures, which does have an encryption piece of part of it when we encrypt using our private key, the hash of a message. So I'm not going to get too deep into that as well. And then compliance. Sometimes we're going to have data sovereignty laws or laws that govern us within our architectures, like PCI DSS, PCI compliance, or HIPAA, or GDPR. That's going to say, hey, when you're processing data, as like the credit card company or the person or the organization processing credit cards, PCI compliance says that you need this level of encryption. Also, NSA or NIST standards may apply to your organization when working in the government. You're going to need certain levels of encryption and security to meet certain enclaves, right? Like secret or top secret networks. Okay, and then we have the different states that our data can live in and how we apply encryption to those different states. So data in transit. This is our data in motion, right? This is when we're just going on the wired or wireless network over the internet, right? Typically, we like to think about this as, okay, from our trusted zone, let's say I am sending an IAM to another user within my local subnet. We open up Teams. We're on the same exact subnet. Do we worry about data in transit encryption at that level? Maybe, right? If we're very secure, yes. We want to make sure that no matter what, when we have data leaving that NIC card, that it's encrypted, whether that be with TLS or over like a site-to-site VPN tunnel. Data in motion or data in transit, we apply encryption to that, okay? Now, when you go to a website and you type in HTTPS, that S means it's secure, and we're using the transport layer security to actually encrypt that session end-to-end, okay? Meaning that if I did a Wireshark capture and I tried to look inside an HTTPS session, I won't actually see the data. I won't see the data payload. I won't actually see what's going on, okay? That's data in transit. We apply encryption to data in transit using TLS, IPsec tunnels, things like that. Two of the biggest, most common ones we see. Data at rest. So sometimes our data is not in motion. That means it's getting stored somewhere on a hard drive, solid state drive, a USB. This could be talking about something more robust like a SAN, a storage area network, or a NAS, a network attached storage. When we have data at rest, whether that just be on our Android phone, a USB, our computers, or whole network attached storage, or a whole storage area network, we want to encrypt that data. We want to make sure that nobody can just go see our data at rest, okay? Think about this in a more security sense, like ransomware. If we get infected with ransomware on a computer, one of the things they do is encrypt it so you can't access your files, and then they say, oh, pay me, whoever that malicious actor is, pay me in this amount of Bitcoin and I'll decrypt your files and give you access. That's full disk encryption, right? That's what ransomware does. But on the flip side, right, as a network engineer sitting in a NOC working with a SOC, we want to make sure that our data at rest is secure, that we at least understand that. So full disk encryption, things like BitLocker, FileVault. We put BitLocker on our Windows machines, and you have to put in that BitLocker PIN, or you can't access your operating system. We have file level encryption, so we can encrypt individual files or folders that may be sitting on our desktop or on our work machine. Using something like Veracrypt. So example of this, encrypted hard drives or databases. Now I just want to pause real quick before we just start diving into these different concepts. As a network engineer or someone studying to be a network admin, senior network engineer, if you're not too experienced, you may be wondering why we care about security so much. Why is this a whole section in the Network Plus? And that's because as the modern day network admin, not only do we have to worry about implementing security on our network infrastructure, but we have to be able to intelligently speak to security concepts throughout the whole enterprise when working in a team environment, right? Because it's not just network engineers that enable the business to do IT processes, right? We have a SOC, we have development teams, and they all need to know a little bit about our job so we can have good synchronization. And when we go to those meetings and we talk about our IT infrastructure, or we go to the weekly change management meetings, we understand the vernacular and language of security. And it does apply to us too, because as network admins, we apply security concepts on the network. Think if you're a firewall admin, or you're working with Palo Alto or ASA or Fortinet, that's security. Back to the actual lesson now. Okay, certificates. So what is a certificate? So a digital certificate is something like an X.509 certificate that gets created during our, when we do an SSL cert request, part of the whole PKI, the public key infrastructure. But at the end of the day, it's an electronic document used to prove the ownership of a public key. It includes information about the key, the identity of its owner, and the digital signature of an authority that verifies the certificate's legitimacy. And the perspective of PKI, that could be like a certificate authority, whether that be a global one or one internal to your enterprise. So key characteristics of certificates: data integrity. It ensures that data transmitted between parties has not been altered. It can provide authentication. So certificates play a vital role in validating the identity of users, devices, and servers. For example, in the Department of Defense and other organizations too, but that's where I came from, we had things called common access cards. So we would plug those into card readers on our computers to actually log into our enterprise, and there was a digital certificate on that. So that was one of the ways we authenticated. And then encryption. It can encrypt data as well. So the digital signatures on there, since it's a public key, we could publish those to something like a global address list and then start encrypting emails within our organization. So then we have the public key infrastructure. So as much as I'd love to do a 20-minute deep dive on PKI, if you're looking for that, go to my Sec Plus course. That's not what this is going to be about. This is going to be a quick overview to just get you familiar with it as a network admin, what the public key infrastructure is. And this really enables the whole internet architecture of security when it comes to like server to client connections. When I go to a web page and I type in HTTPS, without a global public key infrastructure with certificate authorities assigning X.509 certificates to websites that enables them to do the transport layer security cipher connection, right? We wouldn't have TLS. We wouldn't have that protection. Now, we're just going to go over this slide, highlight it, right? Go over some key terms in there to get you ready to pass a Network Plus exam. But again, if you want a deep dive, I'll put it in the description on this video, a link to our Security Plus course that dives deeper into this. But what is it? So public key infrastructure is a system that helps manage digital certificates, which are used to secure communication over networks. It ensures that users and devices can communicate safely, keeping data private and unchanged. Some key components are certificate authority, and then the digital certificate that the certificate authority creates. There's other key components like OCSP, certification revocation list, registration authorities, the actual requester, the CSR, certificate signing request. These things that we're not going to dive into. So sorry I keep bringing it up. It just feels... Anyways, let's just keep going. Digital certificates. These are part of a key component in the public key infrastructure. These certificates include important information like the public key and the identity of the certificate holder. They act like digital ID cards for that website that may be requesting an SSL cert, TLS cert. So PKI certificates help ensure that data stays intact during transmission and confirms the identity of users' devices, which helps prevent impersonation. Self-signed certificates. So in an organization, we may set up a certificate authority, and that's like our centralized way of doing a public key infrastructure. But we may have something less centralized, maybe like a distributed system, and that's where we have self-signed certificates. So these are digital certificates that are signed by the person or organization that created them, rather than by a trusted certificate authority. So this is mainly for internal purposes or testing environments. Now, kind of to put this in perspective, imagine I deploy a website like trepatech.com. And now I want to have valid HTTPS sessions for all of our users. So I'm going to go get an SSL cert from a certificate authority, a trusted certificate authority that web browsers trust. So whether you're on Chrome, Firefox, Edge, Safari, baked into that web browser is going to be trusted certificate authorities. And then when I get a digital certificate from that certificate authority with my public key, right? And that's what I post, that's what I make public. So when we do our TLS HTTPS sessions, right, with users, it's trusted. Chrome's like, yeah, let's do TLS, but also I trust that certificate. I'm validating that. Well, maybe within an organization, we don't need that kind of centralized administrative burden of us running our own certificate authority, so we just do self-signed certificates. So the key features, users generate their own certificates without relying on a CA, so we'll still be able to do what we normally do with our certificates that are self-signed, but maybe a web browser won't recognize it as valid, but it doesn't mean you're not still doing that HTTPS session. Since they are not signed by a trusted CA, self-signed certificates may not be recognized as secure by browsers or their system, which can lead to warnings. Use cases, development and testing, and internal networks. Okay, now let's dive into identity access management. I like to think of this as like the fourth major compute element. Like networking, storage, compute, and especially with our hybrid cloud environments, IAM is just as important, and it's always been important, really, in our modern day environments. And what I mean by that is identity access management. That is one of the main roles when doing system administration, cloud administration, setting just permission levels, even on a SaaS application that you're creating. IAM's always going to be important, okay? So identity access management. This is a framework that helps organizations manage digital identities and control access to resources. It ensures that the right individuals have the appropriate access to technology and data. So key features, IAM is going to involve authentication, authorization, and also something called accounting or auditing, okay? So we look at AAA, right? Authentication, authorization, and accounting or auditing, kind of very, very similar. The actual AAA acronym, the last A, is accounting. We're going to have protocols and technologies that enable us to have good identity and access management. So authentication. This is the process of verifying an identity of a user or device. So this is when you type in username and password, and it says, oh yeah, you have an account created at this resource, whether that resource be a web application or your actual enterprise. Now, authorizations are the permissions that get set against your account. So I have an account, but now what do I have access to within that network that I'm trying to access, or that enterprise, or that web application? For example, if you purchase our Network Plus course on our learning management system, academy.trepatech.com. If you purchase Network Plus, we set a permission on your account that says you have access to this course. But we have 20 other courses on there, 10 other courses on there that it's set based on permission. Your permission is a Network Plus, but not these other courses. That's authorization, pretty much setting permissions, okay? Determining what an authenticated user is allowed to do, and this could be based off their role. This could be based on what they purchase. This could just be based off what you feel they need as an individual to do their task, which is like role-based access control, kind of repeating myself. Okay, so with the authentication piece, we're going to go over something called multi-factor authentication and then other technologies that enable authentication, authorization, and possibly accounting. So again, authentication is the process of verifying a user's identity. So we're going to go over something called MFA, multi-factor authentication. With multi-factor authentication, this is verifying a user based off two major factors. 2 or 3, really. But it has to be 2, at least 2, to be multi-factor. So what are those? That is what a user knows, so what you know, which is something you create, something that you made up. This is going to be a username, password, a PIN. Another factor could be something that you have. This is something that was given to you, something in your possession. You didn't create it. It's not something you thought of, something that was given to you. This could be a physical token. This could be your cell phone with a third-party app on there that gives you a code. This could be a push notification that says, yes, that is me logging into my YouTube account. This could be an MSS text message that's sent to you. All these are something you have because that's in your possession, a physical phone that you need to have access to. Without it, you can't log in or you can't verify yourself. So we have something you know, username, passwords, pins, something you have, cell phones, digital tokens, or excuse me, not digital tokens, like physical tokens, a YubiKey, push notifications, SMS messages, an authenticator app. And then it's going to be something you are. That's your biology, or what we call biometrics. So this is doing a face scan, a finger scan, an iris scan. This is your biology that's identifying your user account as well. So this is using your Face ID, right? That is something you are. So to recap, the multi-factor authentication, 3 major factors are the something you know, something you have, and something you are. Okay, and then we have single sign-on. So a single sign-on experience allows you to use like federated applications or technologies to use a third party to access a resource. Let's break that down. So what we mean by single sign-on experience, every website does this with a major identity provider. We do this on Trepa Tech. So we as Trepa Tech, that resource that you're trying to access, let's call it a third-party app in this case, trepatech.com, you're trying to get access to it. Well, instead of creating an account on trepatech.com internal to our databases and authentication authorization, we have a sign-in with Google. So we created that single sign-on experience for you by on the back end enabling something called OAuth 2.0, doing an API request. But anyways, so you see sign in or sign up with Google. So as long as you have a Gmail account and you have access to that Gmail account, you hit sign in with Google. And on the back end, that third-party app, us Trepa Technologies, we already had that trusted session with Google, but we're going to forward that request to them. And then you're going to see the Google sign in, right? And you're going to verify yourself. Google verifies your credentials, then sends us something maybe like a JSON web token that says, yes, this person, we verified them. And since we have that trust with that identity provider, that centralized identity provider like Google's authentication servers, we're now going to grant you access to our resources. So that's single sign-on. The application, the technologies in the background that make this happen could be something like SAML, the Secure Assertion Markup Language. This could also be something like OAuth 2.0 or OpenID Connect. Those are the technologies in the background that make that centralized identity provider be able to integrate with a third-party app like trepatech.com, granting you or giving you a single sign-on experience. Okay, Radius. So moving on to something kind of more network-based. The Radius protocol stands for Remote Authentication Dial-In User Services. I know it says dial-in. It's an older technology, but it still checks out. At least it's still widely used. Like with network access control, this AAA protocol, Radius, it's what you're going to hear. It's a AAA protocol, Radius. It's going to be used all the time in 802.1x and network access control. In Wi-Fi environments, Radius is used to actually verify like WPA 2 and 3 and enterprise mode, right? As the actual authentication, authorization, and accounting protocol. So Radius, that's going to be the technology that enables a AAA server to authenticate, authorize, and do accounting functions for your enterprise. So a system used to manage and control access to networks. It verifies users who are trying to connect and checks their credentials, making sure they have permission to access the network. Okay, LDAP, the Lightweight Directory Access Protocol. So this is another, we don't call it a AAA protocol, but it's another authentication protocol. If you ever worked in a Microsoft environment with on-prem Active Directory domain services, and you've managed domain controllers, and you've had users sign in using the credentials you created on Active Directory, you've used LDAP. So Lightweight Directory Access Protocol, this is a protocol used to access and manage directory information like user accounts and permissions over a network. This is how you access that database, or do a request to that database that's storing your actual credentials. SAML. This is going to be another one of those protocols that's used on the web to have that third party rely on an identity provider. So it's just one of those technologies that enables that single sign-on experience. So this is a standard used for exchanging authentication and authorization data between different systems securely. It allows users to log in once and access multiple services without needing to enter their credentials again. Again, that single sign-on experience. TACX, going to be another AAA protocol, same as Radius. Originally was Cisco proprietary, but now a lot of it's open standard. Either way, it's going to do a lot of the similar functions that Radius does. Like if you deploy a Cisco Identity Services Engine server, you can use TACX to make sure that network devices like Cisco access switches, Catalyst switches, are being actually authenticated to the broader enterprise, right? So TACX, another one of those AAA protocols that's going to provide authentication, authorization, and accounting for us. Big difference between the two, Radius and TACX. Radius is UDP, goes over port 1812. TACX is TCP. I can't remember the port. Maybe I'll put it up in the post here. I think it's 179, but don't take my word for it. I'll check on that when I edit this video. And then another major difference is Radius combines the authentication and authorization packet requests and responses. So it'll be one packet that contains the authentication, authorization, requests, and responses between client and server, or supplicant and server. Where TACX has an individual packet for each part of that AAA. Meaning if I'm doing a TACX authentication request, that's all I do, just authentication. I don't put authorization in that individual packet as well. It's all separated. Then we have time-based authentication, something that's used a lot when we're doing like implementing least privilege and stuff, something we do a lot when we do multi-factor is time-based authentication. So this happens with me, right? If I try to sign in to my trepatech.com account, I get a notification on my phone saying, is this you trying to access? And if I don't do it, I don't know the actual time, but it feels like if I don't do it like within 10 minutes, hit yes, that's me signing in, it times out. And then I won't be able to log into my Google account. Okay, got ahead of myself. Now we're getting into authorization and least privilege. So authorization, this is the process of determining what an authenticated user is allowed to do. This is permissions, right? So you can set permissions in a lot of different ways, right? Depending what system you are, really depends how you do it. In Linux, we have our read, write, execute permissions for the owner, user. I forgot the third one. And then in like Microsoft Active Directory, we have a lot of different ways we can do like RBAC, role-based access control, or set permissions, right? We have our member of groups, things like that. But we're going to just be, holistic view, top-down approach. As an enterprise, we're thinking of how we're going to do authorization, how we're going to set permissions without getting into the nitty-gritty. Well, we have this kind of storage area network, or we're an Active Directory, or we're a Linux shop. Really what we're trying to do is set this broad policy. It's called least privilege, which is a security principle that says, hey, ensure users have only the minimum level, exactly what they need to perform their jobs, nothing more. Because we don't want that privilege creep to happen where we give someone access to this shared drive, forget to take it away. No, we're giving you exactly what you need. Principle of least privilege, okay? This is huge in zero trust architecture as well, zero trust network access. Then we have role-based access control. So this is like this is a big standard for enterprises, RBAC. It's just a method of managing user permissions based on their roles. It's just an easy way for us, if we're security administrators, system administrators, saying, let's onboard someone, they're part of the marketing department, so we're going to give them permissions based on their role. They're the marketing, I don't even know, they're a part of the marketing team, right? If they're coming into the IT team, well, what are they? Are they a cloud, system, help desk, network? Are they part of our DevOps team? So if they're coming in as a junior network admin, we're going to set their permissions based on that. That junior network admin shouldn't have access to our databases, right? He or she should have access to probably the layer 2, maybe some layer 3, the, switches, maybe some access points, maybe some services. Other ways we can control authentication or access with geofencing. This is something that's kind of getting more into the real world, kind of saying, hey, that computer you're working on in our major compound, maybe we're doing like a bunch of data research for the government. So that stays on our compound. If you take that computer outside our compound, we're going to notice that with our geofence we have set up, and we're going to say, you can't get access now. We're going to shut off that NIC, or you're going to shut off access to the internet. So geofencing is a location-based service that uses GPS or RFID. GPS is probably the right way to do it, right? Because if you try to do like IP, like, oh, as long as the IP is on the East Coast, we're going to let you work. That's easily thwarted. It's put on a VPN, right? And then maybe the IP will always be on the East Coast and you're in China somewhere, right? So this is using GPS or RFID to create a virtual boundary around a specific geographic area. And when a device enters or exits area, it's going to trigger a response or action. So enters, you get access. Exit, no access. Typically is how we're going to do it, right? All right, awesome. This video was a little bit longer than I thought, but we're going to still go over our quiz. I'm going to pause the video and I'm going to bring it up. All right, so let's go ahead and do our quiz now. I'm on our learning management system. If you want access to this, check the description below. Go to our website. You can purchase this for $69.99. Get all of our lessons, quizzes, exams. Let's go to this lesson. We're on week 3, domain 4.1. And let's take our quiz. I'm going to zoom in here so we can see it better when I put it on YouTube. Okay. So domain 4.1, explain the importance of basic network security. We're going to go over logical security. So question 1, what is the key difference between public key infrastructure certificates and self-signed certificates? And what we mean by that is, with PKI, we have certificate authorities that are trusted by web browsers. Self-signed certificates, it's exactly what it says. Just a user signs it or individual signs it. It's not backed by a certificate authority. PKI certificates are considered more secure for public use, while self-signed certificates are typically used internally. I think that's what I'm going to go with, guys. A here. PKI is not used internally. PKI does require public-private key pairs, and they do require validation. So I'm going to submit my answer. Let's go. We can see our explanation down here if you want to pause the video and read that. Question 2. What is the main purpose of the principle of least privilege? That's also going to be A, to restrict users to the minimum access necessary to perform their tasks. D would have been R back. But anyways, let's go ahead and you want to pause the video, look at that explanation. Question 3. Which of the following best describes geofencing in the context of network security? So it's going to be C. Limiting network access based on a user's geographic location. If you want to read the explanation, go ahead and pause the video. Question 4. Which of the following protocols is typically used to verify identity information stored in a directory, such as a corporate Active Directory, for network authentication? So Active Directory, what do we think here, guys? A protocol that verifies stored identity in directory. Probably going to be LDAP, the Lightweight Directory Access Protocol. There's the explanation. Pause the video if you'd like to read. Question 5. Which of the following is a key feature of multi-factor authentication? It only requires username and password. No. It requires multiple forms of verification, such as a password and fingerprint. That's not like, oh, that is multi-factor, but that is one way to do it. Because a password is something you know, and a fingerprint is what? Something you are. That's 2 of the major factors. They call it a feature in this question. That's okay. That's going to be our answer, guys. Here's the explanation if you want to pause the video and read. Question 6. Which authentication protocol is commonly used to provide centralized authentication, authorization, and accounting for network users, especially in wireless networks? So I'm going to go with Radius. TACX could do this, though. TACX could do what they're saying. But in wireless networks, when we're doing WPA Enterprise, whether that's WPA 2, 3, and when 4 comes out, it'll be the same thing. That's the AAA protocol that we typically see in wireless networks, okay? So I'm going to go D, Radius. Pause the video if you'd like to read the explanation. Question 7. What is the main advantage of using role-based access control in an organization? I don't like these answers. I'll probably change them, but it's probably B. It restricts users to the minimum permissions needed for their role. Oh, no, sorry. That is exactly what it does. I don't know. Just had a little... Anyways, probably need a break after this video. But yes, RBAC, role-based access control, grants permissions, sets permissions based on exactly what that user is going to be doing in your organization. So that is B. There's the explanation. Pause if you want to read it. And the last question here, what is the primary purpose of encryption in network security? So plain text to ciphertext. Definitely not D. It doesn't make it faster. If anything, you can slow things down because the compute resources necessary. That's going to be C. To convert data into a secure format, preventing unauthorized access. There's the explanation if you want to pause the video and read. All right, so there's our results. We got 100%, guys. Let's go. So I want to thank everyone for viewing. If you're interested in getting access to our academy or our learning management system, hit that link description below. If you want to come to any live virtual training, reach out to our team. You can go on our website, put in a contact us form. Like, subscribe, share with your friends, hit that bell, and I'll see you in the next video.